Okay, so on note 7.1, we're going to be analyzing quadratic functions on the calculator. So first thing that we need to do on this first example is go to y equals on your calculator. You're going to type in the quadratic function x squared plus 5x plus 4, and you're going to graph it. The first thing that we're going to find is our vertex. What you have to determine before you can find the vertex is if it's a max or a min. And remember, we talked about the vertex. If it's at the bottom of the parabola, that means it's a min. So you will need to go second, calc, or trace. Minimum is number 3. Now, it says left bound. You're going to move your cursor to the left side of the vertex. Doesn't matter where it's at on the left, just as long as it's on the left side. Press enter. And then you're going to move it over to the right side. Press enter. And then it says guess. You need to press enter one more time. And so we have our minimum point, which is our vertex. It's negative 2.5, negative 2.25. We'll just always round to 2 decimal places. So there's our vertex. To find other points on your parabola, we're going to do second table or graph, and I'm going to just make a little table here. I'm going to go from negative 6 to negative 610, negative 5, 4, negative 4, 0, negative 3, negative 2, negative 2, negative 2, negative 1, 0, 0, 4, and 1, 10. Okay, so let's go ahead and start plotting those points. So negative 6, 10. Negative 5, 4. Negative 4, 0. Negative 3, negative 2. And then remember our vertex is negative 2.5, negative 2.25, and then we have negative 2, negative 2, negative 1, 0, 0, 4, and 1, 10. I'm going to go ahead and draw our parabola, so sketch it through there. Okay, we're going to draw our axis of symmetry. Remember, it's a straight dotted line that goes through your vertex. We talked about this before the break. Axis of symmetry is always x equals. It crosses the x-axis the same place as your x value of your vertex, which is negative 2.5. We already found the vertex to be a min, so we need to circle that, and the minimum value is that y value of your vertex. So if you look at your y value of your vertex, it's negative 2.25. Now, the domain and range we talked about before the break. On domain and range, domain of any parabola that opens up or down is all real numbers. We're going to learn how to use interval notation instead of set notation, which we've already gone over. So instead of putting all real numbers here, we're going to write set notation. Set notation, you use parentheses and you use brackets. You're using brackets when it's equal to, you're using parentheses when it's not equal to. So if it's all real numbers, that means anything from negative to positive, any real numbers, okay? So you've probably heard of infinity before. So we would have a negative infinity to positive infinity. So I'm going to put a comma in between, and then we're going to put parentheses around both. Parentheses, it doesn't include it because there's not an actual stopping point or an actual starting point. So we're going to put parentheses around those. Now the range, if you look at your y-axis, that smallest y value we already talked about was negative 2.25. So normally we would have y is greater than or equal to negative 2.25. domain would have been all real numbers, the way that we use set notation using your brackets. That's how we've done it in the past, okay? On the range, we're going to go from anything greater than or equal to negative 2.25, okay? So that means we're going to include negative 2.25. We will include it, so that will be a closed, and we're going all the way to positive infinity. We won't include it, so that will be a parenthesis there. Okay, so that just tells me. Okay, so now we're going to find the roots. The roots, remember, are your x-intercepts. So where it crosses the x-axis, so it crosses it at -1 and at -4. So those are your two roots. Remember not to put parentheses around it. If you wanted to set it up as an ordered pair, it would be -1, 0 and -4, 0. But not -1, -4 as an ordered pair. Let me go back. Okay. Alright, so now we're going to look at number 2. So the first thing we want to do is go to y equals. We're going to clear it out. We're going to type in -3x squared plus 5x plus 7. Okay, so graph it first. See what the parabola looks like. Notice this time our vertex is at the top. So it's a max. So this time we're going to do second calc, and we'll choose maximum, which is number 4. Left bound, your cursor needs to be on the left side of the vertex. Press enter. Right bound, press enter, and then press enter again. We're going to round to 2 decimal places, so that would be 0.83, 9.08. Okay, so then we're going to find the other points that's on our parabola in the table, second table or graph. Just plot the ones that you're able to plot. I'm going to make a little table here for me. -1, -1, 0, 7, 1, 9, 2, 5, and 3, -5. Now sometimes it's not going to be symmetrical depending on where your vertex is. So I'm going to go ahead and plot that. So my vertex has 0.8, 3, 9.08. And then we have -1, -1, 0, 7, 1, 9, 2, 5, and 3, -5. Draw your axis of symmetry, which goes through your vertex. And then you can connect your points. Axis of symmetry will always be x equals the x value of your vertex, which is just where it crosses the x-axis, so 0.83. That maximum value is that maximum y value at the top, so that is 9.08. Normally our domain would be all real numbers, but we're going to use interval notation, so we're going to go from -infinity to positive infinity, and it will always have parentheses when it's all real numbers. The range, normally it would be y is going to be less than, because it's everything below 9.08, and it will include it. So it will include 9.08. So that's the highest point. So that needs to be on your right side, because that's the maximum number that you're going to have. It will include it, so it'll be a closed bracket. And then it goes all the way to -infinity. So that needs to be on the left side, because that is where your left side value goes, the negative side. Okay? Alright, and then your roots. where it crosses the x-axis. Now notice on the previous example, we just had whole numbers as our roots. We don't on this example, so we're actually going to have to find them on the calculator. Okay, so to find your roots, you're going to do second calc. You're going to choose number 2, which is 0. Zeros and roots are the same thing as x-intercepts. So it says left bound. I'm going to find the left root first. So I want to be on the left side of this root. Notice the parabola on the left side of that root is going down. So I need to be below the x-axis there. And then right will be above that. Your arrows on your calculator should face each other on the inside. And then you should press enter. It should say 0 when you actually have your root. So rounding to 2 decimal places would be negative 0.91. That's one of them. Now we need to go and find the other one. So repeat that, second calc number 2. This time we're finding the right side root. The right side of this x-intercept on the right side is above the x-axis, and then the right side is below. The 2 arrows should face, and then press enter. Anytime it says 1e to the negative power or whatever, that's going to mean 0 there. So y is 0, which means you have an x-intercept. So our root would be 2.57. So those are your 2 roots. Okay, last one. So first thing, go to y equals. Type it in, x squared minus 8x plus 16. Graph it first. Okay, so notice that it is min. It's at the bottom of your parabola. So I'm going to do second calc min, which is 3. My cursor needs to be on the left side of the vertex, which it is, so I'm going to press enter, and then move over to the right side of your vertex. And then, I'm going to have to redo that. Yep, second calc min, left, right. So that would be 4, 0. Since our vertex is 4, 0, that's also our root. And remember, if your root and your vertex are the same thing, that's called a double root, which means it's also your vertex. Okay, so let's go to the table. Second graph or table. We're going to plot the points. So we're going to go from 1 to 7. So 1, 9, 2, 4, 3, 1, 4, 0, 5, 1, 6, 4, and 7, 9. Okay, so plotting the points. 1, 9, 2, 4, 3, 1. 4, 0 is our vertex, also our root. 5, 1, 6, 4, and 7, 9. So there's our parabola. And then draw your axis of symmetry. So our axis of symmetry would be x equals 4. The minimum value, which is the smallest y value used, the y value of your vertex is 0. Domain would, in set notation, would be all real numbers, but interval notation would be negative infinity to positive infinity. And it will always be parentheses on those two, because it can't equal negative infinity. It just keeps going and going and going. Okay? Alright, so then the range on this one, your smallest y value is 0, and it's everything above it. So we're going from 0 to positive infinity. It will include 0, but it will not include positive infinity. So that is your interval notation.